alla med? Då är det nog så här att vi får börja här helt enkelt. Ja, och då önskar jag välkomna till detta webbinar som handlar om som vänder sig till installatörer och konstruktörer helt enkelt. Där vi kommer visa hur vi undviker kollisioner och effektiviserar arbetet. Och vi på AEC är ju ett företag som vänder sig till byggbranschen. Vi jobbar mycket med folk som gillar AutoCAD och Revit naturligtvis. Vi erbjuder utbildning och olika typer av support kring de här produkterna. Vi jobbar med AGACAD som gör Revit mer lättarbetad och vi ser att många tråkiga repetitiva uppgifter kan automatiseras med hjälp av AGACADs produkter då. Och det är ju en lösning som bygger på mycket erfarenhet och utvecklas ständigt då, i takt med att kundernas behov kommer in. Så att det vi ska se idag får ni se nu helt enkelt. Så jag lämnar över till AGACAD här som kör den fortsatta presentationen på engelska. Jag ska också säga det bara att vi har en kampanj samtidigt på de här produkterna som gäller fram till den 16 december då. Johan Holmqvist att jag glömde att säga, kom in lite sent här. Okay, so go ahead, AGACAD.
Okay, so thank you, Johan. Today this is our team, and thanks Johan for a good presentation of us. So today we have three of us. It's Johan, Jokubas, and Valences. One is from ISC, and two of us are from AGACAD, and I think Johan just told a bit about ISC and AGACAD collaboration. And today we will speak about making openings in structures using add-ons for Autodesk Revit software. So we will speak about cut opening and smart assemblies software. And we will announce a new technology for sharing information in between architects and MEP engineers and vice versa. So basically the workflow will look like this. The architect or structural engineer is making a model. He's sending a copy to MEP engineer. The MEP engineer is linking the MEP and structural models into one model. Afterwards, he inserts the openings using cut opening software. He makes changes like he's making the openings bigger, smaller, or something, and he is sending the final result back to structural or architect, structural engineer or architect, and he inserts everything into the model. So in this webinar, we will learn how to cut openings with predefined opening size, shape, joining distance, etc. As well, how to update holes in accordance to the latest changes of the model, how to transfer all openings for structural engineer, as well how the structural engineer will insert everything into the structural file, and how to make afterwards how to make the assemblies, as you can see on the screen, how to make the assemblies of the prefabricated walls as the example today. So we will use two different softwares. We'll use cut opening. So the cut opening is making holes for ducts, pipes, cable trays, and conduits where they clash with structural model. And we will use smart assemblies. This is shop drawing generation with corresponding views and dimensions, updates, etc., etc. So I don't want to speak about all this just literally, and I want to show you how it works in real life. So here we have prepared our model. This is a beer brewery, so we will show all our examples on this little part of the model. It is cut all around. So basically we have clashes in between MEP pipes and ducts with the structural model. So I have MEP linked into my structural model, and I'm going to make the interference check in between, as example, walls, and I will use linked file, and I will run the clash detection between walls, ducts, and pipes. So basically what I'm doing, I'm just using simple Revit stuff, simple Revit interference check report, and I'm exporting that information on my anywhere, as example today on my desktop. The next step after interference check is done is to go and see what kind of configurations you can adopt here. So as the example, we have different MEP line-based element information over there. As well, we have different tools and different configurations for that. So basically our software is working with some kind of ranges, like from 0 to 50 I will always insert rectangular opening that has cut offset of 100 millimeters. From 50 to 80 I will use, I don't know, round opening, and I will make 150 millimeters offset. Or you can add apply defined opening size. That means you will always have the same opening for all the elements that are from 0 to 50 or something like this. So you can choose this. As well, we have some extra configurations for joining openings. So that means if the openings are near each other, we can make auto joining of them. So we will make one hole instead of two little holes. If the pipes or ducts will be in the range from 0 to 200, and we will always auto join them if the intersection offset, like the distance between openings, are less than 50 millimeters. So you can add your own configuration. You can check what you want here, etc., etc. As well, we have the interference check. So here you can add openings for partial interference. So I mean, if you have, as example, if you have a pipe that is connecting a toilet or a trap or something like this from the floor, so you need to make an opening for those elements. So we can use our partial interference feature. Or as the example, you have a wall-mounted ear terminal, and you want to make an opening for it as well. You can use our software. So after you've done your configurations, you just save that, and you can go and combine your interference check. I mean, you are combining the interference check with your configurations using read interference data. So after this, you just browse for your file. You just go on your desktop. You just browse for interference check information. You choose one from these configurations that you have saved. Basically, we are giving the cut opening configuration default, and you just can go with just simply with next button. As you can see here, we have everything written. We have cut offsets, we have additional top cut offsets, bottom cut offsets, markings, lots of interesting stuff here. We have on the left side a tree where you can just group your elements by some levels, by pipe types, duct types, etc., etc. After you did all the check, you checked all the stuff that is here, you just export the XML view. So I just export it on my desktop, and I'm closing the dialog, and I'm using the next tool that is saying insert MEP openings. Okay, let's go and insert. So I'm browsing for the XML file that contains both clashes and configuration. After this is done, I just click next and I click insert. So as you can see, I'm inserting all the openings. The openings are joined, the openings are sized, the openings are just placed. And the final result looks like this. So we have holes all around. We have auto joined, like we have two pipelines over there, as you can see, and we have only one pipe. So that means the software just checked how is it possible to auto join them. As well, somewhere here, one big hole, one little hole, etc. So you can do whatever changes you need. We are giving extra parameters. We are giving extra parameters to make some cut offsets, so you can change the offset. You can do whatever you need. As well, we have some extra parameters for host information, level information, system classification, name type, who inserted the opening, what was the configuration, what is the insertion date. As well, we are working on the possibility to calibrate in between our colleagues, like the architect can write some comments to the structural engineer, etc., etc. So this is really nice. You have the opening elevation, mark, shape, etc., etc. So that means you can fully tag your openings, etc. But as I am MEP engineer, so this is my workplace, and I just made all the changes how the opening should look like. And in this place, I'm using just MEP openings revision. I have some information that we changed the cut offset, so I can agree with last changes. If something will be moved in the model, you can agree or undo last changes, etc., etc. So I just agree with last changes, and I'm going to export all these openings to my structural guy. So I'm exporting that, and I'm placing that on my on our FTP, where we have the possibility to come together and place our files. And I just sent my file to my colleague Valensas, and he have true structural model. So that means he should insert the openings to that model. So I'm giving the presentation to my colleague Valensas, and he will show what's going on afterwards.
Okay, thanks, Jokubas. And now you should see my screen and my project, my model of structural engineering. And I don't have openings yet. I just have linked model of MEP guy, and I will insert openings, and I will talk about how can I handle these openings, and how do I work with preparing drawings for my walls. How can I update my walls and drawings with these new openings. So okay, for this I will use now this one solution, cut opening also. So I will insert MEP openings. I will browse to the place where I know that MEP guy has created the XML file for me. So I will open that. Okay, so click next. And now I have this table. So I can run through and take a look where is my openings located, what kind of openings, where are they located, and I can just insert these openings into my model. It will cut my walls, it will cut my structural framing or columns and so on. It depends on where the openings goes. So I will close down this one. And now you see I have these openings already in my model. So my walls has these openings. So the same as in Jokubas model. And what can I do now? I have some drawings already prepared, let's say for this kind of drawings. I have a sheet with drawings, dimensions, and views placed on the sheet. Then I have dimensions for all the elements, but I don't have dimensions for openings. So if I will go, let's say, to this view, to other element also, so I have, let's say, dimension line for the doors, but I don't have the dimensioning for this opening and so on. So for the current assemblies, I should just go to the view, select assembly, and do the update. So now additional line will be added, additional dimension will be added to my opening line, and you will see now that all this view is updated and I will have new dimensions. Okay, so drawing is updated, and now I have this line where I can see like my new opening is also updated. So I have these additional lines. So that's how I updated my model, but let me see if I will go to the section view. Now I have the wall which is not assembly yet. So I will just say a few words how Smart Assemblies works. So this solution, it has configurations which you can prepare. I'll open one of them and just see that I can save my configurations with defined settings. So what can I define here? I can select what kind of views, how many of views do I want to create. It could be just standard views or flipped additional views, some legends and so on. So I can select as many views as I want, then give them a name. I can apply view templates, dimension rules, and dimension rules are described in over here. So again, I have different configurations saved, and I can describe how my main element, for example, my wall should be this dimensioned, then how openings should be dimensioned, non-standard cuts, standard cuts, or holes in my main element, how they should be dimensioned, what should be the limitations of openings, and so on. Then additional rules for the hosted metal details, for the hosted concrete details, rebars, how, what nodes should be included, like I can change the names and so on, and in my language to do this. Then I can position nodes on different sides, like this or like this. I can make some configurations and save them. Okay, and I can apply different configurations for different views. Then, of course, I have configurations for the schedules to automatically create schedules and the sheet template. So I can pick the sheet template which I want to use. How do I want to place my views on the sheet? So when I have these configurations, I select File element, and I can create assemblies or auto-create assemblies, so it will use selected configuration automatically. So I will just do that and just will create this assembly. So note that I just need to select wall, and all the hosted details will be included automatically. Dimensions will be placed automatically, and views will be placed on the sheet according to the sheet template. So I will click OK, and let's see, now I have here assembly also. So I have a gravity point and some other things, and let's see how does it look now. MW3, and let's go to the sheet. So we have a sheet prepared with drawings placed on the sheet as an in-sheet template. And what do I have here? I have all these dimension lines for the details, and I have dimension lines for the openings also. So you see all these dimension lines up here. So they are automatically created. So that's how I work with Smart Assemblies. So I can update existing Smart Assemblies, or I can create new assemblies and just go through all these updates which are necessary and which comes in different stages of the project. So then I have different commands to update, manage assemblies, modify configurations, or just change configurations, edit configurations, different options in this solution, but in principle, in general, it works like this. And that's what I wanted to show today. So Jokubas will continue.
So I just want to say some sentences about our presentation. So we used the two tools. So that was cut opening, and that was the smart assemblies. But basically, our team has much wider. Maybe the widest range of applications for Revit worldwide. So you can try any of our tools. So we have like smart details for detailing models. We have some tools for Revit add-ons, little add-ons that can increase productivity. Smart assemblies that you saw today. We have floor panels and roof panels. So it's brand new products for paneling the roofs and floors. We have metal framing, wood framing, smart browser for browsing your libraries, BIM Tree Manager for managing your own projects, adding some parameters, etc., and MEP Engineer. So all these tools are in one link, so you can find all our tools in isc.se produkter /AGACAD/ something, and you can download our tools just straight from their website, and just afterwards you will see tools for BIM Dog, just the same as in our computers, and you will be able to use everything, tips and tricks, all the updates. You will be able to use everything that we show today. So after you will get as tools for BIM Dog, this is this blue application. You will be able to click on any of the tools on the list, get a trial, fulfill the information about yourself, get a trial activation code, okay, and after several minutes you will get the email with your activation code, and voila, you will be able to work with the software for 14 days freely. So, Johan, do you have something to say?
Nej, inte mer än att det som står här, att kontakta gärna mig då, Johan Holmqvist. Jag finns på 0708 51 16 03. 0708 51 16 03 som driver lite grann den här frågan om relationen med AGACAD och de produkter vi tillsammans marknadsför där. Och sen som sagt att vi har en liten kampanj som pågår till den 16 december då, som gör att det blir något, eller rätt så bra rabatt faktiskt på den här typen av produkter. Vill ni veta mer om det så får ni gärna kontakta mig. Och som sagt, det går att se den här efteråt, så sprid gärna till era kollegor. Ja, nej, det var ju egentligen det hela. Jag tackar för det. Thank you very much.